In section 9.5, we're going to be factoring trinomials. And these trinomials are going to have this form, x squared plus bx plus c. The important part here, the key is that that leading coefficient is 1. Otherwise, things get a little more complicated. But for now, let's stick with a coefficient of 1. So what we're going to look for are two binomials that look like this, x plus p times x plus q, such that when you add p and q, you get that coefficient b, and when you multiply p times q, you get that constant c. So p and q are going to be integers for our case, and that means they can be positive or they can be negative. And the same applies to b and c here. Those could be positive or negative. So let's look at our first scenario where both b and c are positive. So this will be generally our simplest case. Some people like to set up a little x like this, and then we want to focus on these two numbers, b and c. Now you can write b on top, c on bottom, or c on top, b on bottom, either way, as long as you keep track of which one is which. So if we write b here, we want to remember that comes from adding two numbers. And when we write c here, we want to remember that comes from multiplying two numbers. So an asterisk to show multiplication. So we're going to multiply two numbers to get 10. We're going to add them to get 7. So we can look at what are some different ways we can get 10. We could take 1 times 10, but those add up to 11. We could take 2 times 5. Those add up to 7, which means 2 and 5 are the numbers we want. And what that tells us is that x squared plus 7x plus 10 can be factored into x plus 2, because that 2 is positive, times x plus 5. And if you want to double check that, you could use the FOIL method, or you could set up a box and multiply those out. So we have x plus 2, x plus 5. Here's x squared, 2x, 5x, and 10. So we get x squared plus, these two combine to give us 7x plus 10, which is exactly what we started with. Okay, number 2, here we have c is still positive, but b is now negative. So stop and think about, how can we get a product that's positive? That means the two numbers that we multiply together have to have the same sign. So either they're both positive or they're both negative. So then we look at the sign of b, and we see that's negative. Well, the only way you can have two numbers that add to a negative and are the same sign is if they're both negative. Okay, so now that you know both of them are negative, you can temporarily ignore the sign and focus on two numbers that multiply to 15 and add to 8. So we could take 1 times 15 to get 15, but those add up to 16. We can also get 15 by taking 3 times 5. Those add up to 8. So we end up with a negative 3 and a negative 5. Negative 3 times negative 5 is a positive 15. Negative 3 plus negative 5 is negative 8. So we end up with x minus 3 times x minus 5. Okay, scenario 3, c is going to be negative. So we end up with a product of negative 10 and a sum of 3. Well, if you end up with a negative product, that tells you your two numbers have opposite signs. So one is positive, one is negative. So now that you know that you have one of each sign, ignore the signs temporarily and focus on two numbers that multiply to 10 but have a difference of 3. So if you look at ways to get 10, 1 times 10 is 10, but that's not good because 10 minus 1 is equal to 9. We can also take 2 times 5, that equals 10, and that works because when you look at the difference of those, 5 minus 2 is equal to 3. So that's the pair we want, 2 and 5. Now, which one of them is negative? Well, remember that when we add these two numbers, we end up with a positive 3. That means the larger of these two numbers has to be positive. In other words, the larger of these two numbers has to match the sign of b. That means our 2 is the negative. So negative 2 times 5 is negative 10. Negative 2 plus 5 is 3. So we end up with x minus 2 times x plus 5. All right, let's look at some problems here. So number one, we have factor x squared minus 6xy minus 16y squared. So we have both x and y here. That's okay. Just follow along and see how this works. We still want to focus on that product, which in this case is negative 16, and a sum, which is negative 6. So the product is negative. That means we have opposite signs. So we're looking for two numbers that multiply to 16 that have a difference of 6. So 1 times 16 will give us 16, but they have a difference of 15. 2 times 8 will give us 16. Aha! Those have a difference of 6, so that works. And then we remember the larger of these two numbers has to match the sign of b, so the 8 is negative. So when you take 2 times negative 8, you'll get negative 16. 2 plus negative 8 is negative 6. So we end up with x plus, and now instead of just 2, it's actually 2y, and then x minus 8y. And if you multiply these out, you'll find out you get x squared, and then the outer and inner terms will both be xy, and they'll add up to a negative 6xy, and then 2y times negative 8y gives you negative 16y squared. Now, why do we go through all this factoring? Well, it's largely so that we can solve problems like this. So initially, this is not a very pleasant problem to look at because you've got a trinomial, you've got a quadratic here. Remember, degree 2 here, this means we have a quadratic. And in general, when you have a quadratic, you'd like to see it equal to 0. And here, it already is. That's good news. So now we want to factor that if possible. It doesn't always work, but we're trying to give you some examples where it does. So we're looking for two numbers that multiply to 12 and add to 7. They're the same sign because we have a positive product, and that means they're both going to be positive because we get a positive sum. So to get 12, we could take 1 times 12, but those add up to 13, not 7. We could take 2 times 6, but those add up to 8, not 7. We can also take 3 times 4. Those do add up to 7. So we end up with 3 and 4. So we can rewrite that trinomial as x plus 3 times x plus 4, and we know that that's equal to 0. And now this should look familiar. This should look like some problems that you saw in a previous section where we have two quantities multiplied together give us 0. The only way that happens is if one of those is 0. So x plus 3 could be 0, or x plus 4 could be 0. And then we solve both of those. Subtract 3 to get negative 3, or subtract 4 to get negative 4. So either negative 3 or negative 4 substituted in place of x in this equation will give us a true equation. In number 3, here we have a quadratic, but notice that we have two terms on the left-hand side of the equal sign, and then we've got a constant on the right-hand side. In general, not always, but in general, when you see a quadratic, you'd like to get all of the terms to one side of the equation and set it equal to 0. So in other words, we want to move this negative 14 by adding 14. That means it's going to become a positive 14 on the left-hand side of the equal sign. So x squared minus 9x plus 14 equals 0. And now we see if we can factor that trinomial. So we're looking for two numbers that multiply to 14, add to negative 9. They have the same sign because we get a positive product. That means they're both going to be negative. So we want two numbers that multiply to 14 and add to 9. 1 and 14 won't work, but 2 and 7 will. So we're going to end up with negative 2, negative 7. So we have x minus 2 times x minus 7 is equal to 0. So x minus 2 equals 0, or x minus 7 equals 0. And solve those to get x equals 2 or x equals 7. Okay, number 4 is going to be a little bit similar here. We have x squared minus 5x equals 14. Again, we want to get all of our terms to one side so that we can set this equal to 0. In this case, we need to subtract 14. So it's positive on the right-hand side of the equal sign. It will become a negative 14 on the left-hand side. But now we have our trinomial, our quadratic, equal to 0. So we want to see if we can factor this. So look for two numbers that multiply to negative 14, add to negative 5. So negative product tells us opposite signs. So we're looking for two numbers that multiply to 14 that have a difference of 5. So 1 times 14 won't work. Those have a difference of 13. 2 times 7 will work. And now remember, because we have a negative product, one of these two has to be negative. The larger of the two has to match the sign of b. So that 7 becomes a negative 7. We have x plus 2 times x minus 7 is equal to 0. And that means x plus 2 is equal to 0, or x minus 7 is equal to 0. Solve those to get x equals negative 2 or x equals 7. Right. Finally, in number 5, we want to look at a word problem. So here we have a rectangle of area 52, has length x plus 3 and width x minus 6. If you want, you can set up a rectangle here, and we're trying to solve for x. So we have a length of x plus 3, a width of x minus 6, and in case you had forgotten, to get the area of a rectangle, you take length times width. So we get an area of 52. So let's go ahead and multiply this out. Take length times width, x plus 3 times x minus 6 has to equal our area of 52. So when we multiply these, we'll get x squared, and then we'll end up with a negative 6x and a positive 3x combined to a negative 3x, and negative 18 equals 52. But we would like this to be equal to 0. So I'm going to pull the 52 over to the other side of the equation by subtracting. So we end up with x squared minus 3x minus 70 equals 0. See if we can factor that. So we're looking for two numbers that multiply to negative 70, add to negative 3. They have to have opposite signs, so they'll have a difference of 3. So to get 70, we could take 1 times 70. We could take 2 times 35. These are still much too far apart. These are 33 apart. We need 3 apart. We could take 5 times 14. Those are 9 apart, so we're getting closer. We could also take 7 times 10. And that finally works. Those are 3 apart. So we have 7, 10, opposite signs. So the larger of these two numbers, the 10, has to match the sign of b. So it has to be negative. 7 times negative 10 is negative 70. 7 plus negative 10 is negative 3. So we have x plus 7 times x minus 10 is equal to 0, which means x plus 7 equals 0, or x minus 10 equals 0. Solve those to get x equals negative 7, or x equals 10. But now, because this problem involves some geometry, we need to double check that they both work. So if x equals negative 7, then our length is equal to negative 7 plus 3, which is negative 4. We cannot have a negative length. Therefore, we reject that solution of negative 7. We accept this solution, x equals 10, because if you look at that, if x equals 10, you're going to end up with a length of 13 and a width of 4. These work. So if you can handle this problem, you're going to be in good shape for factoring our trinomials. Good luck.